Good day. This is a case study on the ecosystem health of Los Banos Spring Ecosystems. Calamba and Los Banos are home to ecotourism attractions which includes hot spring resorts and water spas to accommodate the ever-growing number of tourists present in the area. These hot springs are mostly due to the geothermal activities coming from Mount Makiling and Mount Banahaw. However, as a growing demand for these services increase, the finite water supply is slowly reaching its limit and becoming depleted due to the over-extraction of groundwater for these tourism spots. The abiotic components of the ecosystem includes stocks such as natural hot spring waters, the pumped well waters, Laguna de Bay water, and most importantly groundwater. On the other hand, the biotic factors mainly affected are the fauna and flora of the Mount Makiling Forest Reserve that are home to endemic species found in the area. Additionally, it is said that the Los Banos water reserves are mainly consumed by residents and tourists, which consequently gives rise towards a problem of keeping up with the water supply demand and pollution. The study by Hagon et al. In 2015 warned of the inevitable depletion of spring water resources due to excessive pumping for hot spring use and, by extension, a decrease in overall groundwater quantity. The observed rapid increase in hot spring resorts within the past decade and the increasing water demand in the municipality further exacerbates the issue of groundwater and spring water depletion. As groundwater is depleted, the risk of adverse environmental effects such as land subsidence may increase in the long term. Moreover, groundwater depletion would cause an increase in the risk of water scarcity in the affected municipalities. This case study thus intends to use the existing data on the water resource allocations for various groundwater and spring water dependent human uses and natural flows in order to predict the trend of groundwater and spring water depletion over a period of 50 years.
The study generally aims to determine the effects of groundwater pumping for various uses and overpumping of hot spring water on spring water resources in the municipality of Los Banos, Laguna over 50 years. The specific objectives of the study are as follows. 1. Identify components which contribute to groundwater levels and determine their relationships with the spring ecosystem. 2. Predict the trend of groundwater and spring water levels. And 3. Develop a sustainable management plan for the Los Banos hot spring ecosystem.
This case study used Stella Architect software to create a model in the form of a relational diagram connecting the various components of the Los Banos Spring Ecosystem and relevant social and ecological factors, which were then parameterized using secondary data with respect to relevant assumptions. The model was then set to run for a 50-year time frame. Relevant results pertaining to water resource trends, groundwater and spring water amounts, and effects on spring-dependent stocks were obtained, graphed, and interpreted. The model diagram for the Los Banos Spring Ecosystem contains four main subsystems: groundwater, population, spring water, and spring-dependent vegetation. The groundwater system contains the major non-spring-related outflows and the recharge inflow feeding into the titular stock. The population system represents human activities such as increasing population and water use per tourist, which causes increase in domestic water pumping and resort water pumping respectively. The spring water system represents spring and pertinent surface water sources, and the spring resort pumping that depletes said water. Lastly, the spring-dependent vegetation represents vegetation cover that relies mainly on spring water.
Figure 2 illustrates the gradual decline in groundwater levels from about 1,410 million cubic meters to about 1,220 million cubic meters in 50 years, or about a 13.5% decrease in estimated groundwater available. The cumulative water flows are represented in Figure 3, representing the overall amount of water that was pumped from the groundwater toward other sources. Figure 3 was separated from Figure 2 to better illustrate the finer parts of water use, which would be obscured if total groundwater was included, since this latter amount of water still significantly exceeds any single water use. Agricultural use accounted for the greatest share of water use at 710 million cubic meters across 50 years, followed by domestic commercial use amounting to 593 million cubic meters. The latter use rate appears to be increasingly slightly, whereas the agricultural use rate remains constant.
Figure 4 illustrates the rapidly declining trend in spring water availability due primarily to spring resort pumping, which is estimated to exceed spring water amount in 42 years. Vegetation cover is shown to be in decline from the beginning, indicating that the current conditions for the spring-dependent vegetation may already be stressful due to water scarcity. Figure 5 demonstrates how the Los Banos population will be limited by water resources to a carrying capacity of about 200,000 based on estimates by Batola and Santos Rimo in 2014, within just 32 years. Despite this, the trend in domestic water demand continues to rise, clearly outpacing the available usable water supply.
Two major issues are observed in the simulation results. First, increase in tourism does inevitably lead to a dramatic increase in spring water pumping. Based on the simulation, overpumping will exceed spring water availability in 42 years. Overpumping of spring water is depleting water supply and endangering spring-adjacent vegetation, similar to what was observed in a study by Cooper et al. In 2015. Second, groundwater depletion is slowly but surely intensifying due to increased domestic commercial uses, coinciding with increased population. The untapped demand for groundwater stresses its availability for both domestic and commercial use. Additionally, the corresponding urbanization caused by the increase in population growth changes the land and decreases the available area for seepage and recharge. Finally, agriculture is also affected by the depletion of groundwater as irrigation uses this source to grow food needed in sustaining the large and growing populations. These major issues provide us with important points to focus on in management, namely to seek alternative water sources to reduce the load of domestic water use. Next, that urgent water use regulation is required especially for spring resorts. Lastly, the ecology of spring ecosystems themselves must be assessed and monitored further. These options are consolidated and further discussed in the succeeding section, the Sustainable Management Plan.
Now, for our recommendations, this sustainable management plan aims to achieve the following objectives: mitigate groundwater depletion by introducing alternative water use sources, regulate pumping of spring water and ensure strict compliance by spring resorts, and to monitor the quality of spring water and water stress on nearby vegetation.
There are three major issues, each with corresponding proposed actions to be addressed. First, overpumping will be resolved by devising water reuse distribution systems and implementing strict measures in granting water use permits. Next, assessment of water stress on flora should resolve vegetation water stress due to spring water depletion. Third, pollution due to human-generated waste should be addressed through a participatory and community mobilization scheme.
Now let us proceed to our management plan matrix. These relevant agencies will be responsible for the development and maintenance of a water reuse distribution system and for reclaimed water quality monitoring, which will be evaluated against the reclaimed water quality criteria, the flow rate of the spring, and water consumption. For the implementation of strict measures in granting permits for the use of water resources, the DENR and WRB will mainly facilitate the permitting process. For evaluation, there will be comparison of the actual water consumption and declared amount of water needed by the applicants. For the monthly water stress assessment on spring adjacent plants to be led by the DENR, these plant-based and soil-based water stress indicators will be used for evaluation. In the strengthening of the law enforcement of RA 9003 and Municipal Ordinance 200108, the LGU will oversee, promote, and monitor solid waste management activities. Their efficiency will be evaluated through these waste indicators and the number and severity of recorded violations. To assess the universal hot spring regulations to be legislated and to be implemented by these sectors, the number of reported violations will be reviewed. For the monitoring of spring water quality to be led by the DNR and the Research Institute, the following water quality indicators will be used for evaluation. In cooperation with DOST, a research institute will lead further studies on the bioremediation application of hot spring bacteria for the degradation of pollutants, in which the amount of bioremediation enzymes to be produced by the bacteria will be measured. Lastly, the following sectors in Los Banos that are committed to solid waste management will be mobilized to engage in community programs. Their participatory rate in these said campaigns and programs will be evaluated.
Overall, the Sustainable Management Plan incorporates a sense of public responsibility for the spring ecosystems as both a vital natural feature and a tourist attraction to the town, and incorporates best practices and protocols of the national government in spring ecosystem and water resource management at the local government level.
This has been our presentation. Thank you and good day.